Now that we have our fragments, we have to have a way to actually sequence them. So let's say we have a peptide chain, and so I've drawn out the first few amino acids where the side chains are shown as R1, R2, and R3. So this shows the first 3 amino acid residues of a much longer peptide, or rather a peptide fragment in this case. So we can use a chemical method known as Edman degradation to look at this. And so Edman degradation allows us to selectively remove and functionalize the first amino acid of the peptide chain. And so what's added here is a molecule called phenyl isothiocyanate. Oops. Twice in a row. Carbon. There we go. All right, and this will react with the peptide, forming eventually, after adding heat and acid, what we get is a ring of boom. So note this is R1, so this is the what's known as the N-terminus, because this is the amino terminus of the peptide fragment that we're looking at. So this selectively reacts with the N-terminus of the peptide. Okay, and there's a nitrogen here, and thiol. Okay, so this is called phenyl. Let's see if you can see that. Yep. Thiohydantoin. Or, for short, PTH amino acid. And then this can be separated from the mixture, this reaction mixture, and then be analyzed by chromatography in order to identify exactly what the side chain is, and therefore what was the N-terminus of this peptide fragment. So what's nice about this in this technique is that you don't destroy the peptide. So conditions aren't used such that you cleave, conditions are used such that this selectively cleaves. Here. Okay. And then you can continue this in several cycles until you've sequenced the entire fragment of this peptide. And that way, again, by chromatography, we can identify what the sequence, what this derivative of the N-terminus is, and then in subsequent cycles, we can keep looking at the new N-terminus. So in the first cycle, we make this phenylthiohydantoin amino acid with R1, but then what we're left over is a peptide that's shorter by 1 amino acid, where the N-terminus is now this R2. And then we do another cycle of this, and we form a PTH amino acid R2, and so on and so forth, until we've gotten to the end of the fragment, and now we know what the sequence of this fragment is.